2x in the one denominator and x minus 4 in the other. Do we see that? And it has a plus sign in between. When we have an addition sign, what do we first have to have? Common denominator, correct? So I'm going to look at my two denominators. I have x. I have x minus 9 all over 2 and x, which are both snowballs. Yes? And then I have plus 3x over x minus 4, which is a human. Can we make snowballs be humans and humans be snowballs? In real life, can that happen? Can you take a snowball and make it into a human and a human into a snowball? No. You can make it into a snowman, not a human. Okay? So if your denominator, one is snowballs, the other is a human, you have to multiply them by each other. You can't make them be each other. The only way you can make it common is by multiplying them by each other. Okay? So I have to multiply this one by x minus 4. And this one by 2x. So now I actually have to do some distribution because I have multiplication. On the left-hand numerator, so on the left-hand top, I have a binomial and a binomial, a human times a human. So I have to FOIL, right? First outer, inner, last. Or what you need to do is just mainly multiply everything in one term by everything in the other. FOIL is just a nice acronym to remember what to do. So we go first times first, which is x times x, which is x squared. Outside, x times negative 4 is negative 4x. Inside, negative 9 times x is negative 9x. Last, negative 9 times negative 4 is positive 36. All over 2x, x minus 4. Do the 2 and x need to be in separate brackets? No, they could technically be together. It doesn't matter. Then we have a plus sign sitting in between. Our denominator is 2x, x minus 4. And our numerator is 3x times 2x. What's 3x times 2x? 6x squared. So my first goal is to get a common denominator whenever we have addition and subtraction. Yes? My second step is to write it all over 1. Correct? First step, common denominator. Second step, write it over 1 denominator. So I get 2x, x minus 4. And then the top I get x squared minus 4x minus 9x plus 36 plus 6x squared. So first step, common denominator. Second step, write it over 1 denominator. Third step is what? Combine like terms. Combine like items. So here I have an x squared and a 6x squared. So let's call that like a really large xylophone, maybe. I don't know. 1 large xylophone plus 6 large xylophones is 7 large xylophones. Now these are little mini xylophones. Or x-rays. Who collects x-rays? I don't know. That's a lot of x-rays. No, it's not actually. It's a lot of negative x-rays. That's kind of the x-rays I want. None, right? So I have negative 4 x-rays minus 9 x-rays is negative 13 x-rays. And then just plus 36. All over 2x, x minus 4. Now, is it a problem that I haven't stated my restrictions yet? No. The only problem is if you cancel something off, then state your restrictions, right? So if you haven't canceled off at all, you can state your restrictions as long as you haven't canceled. Can I take anything out of the numerator? Any GCFs out of 7, 13, and 36? Trick question. No, there's nothing I can take out of it. So that's going to stay that way. Now this is a trinomial human. It's even bigger. Does that match a trinomial human on the bottom? No. Does it need brackets? No, I just put brackets for effect. I have to follow behind with x can't equal what? 0 and 4. Okay, F. If I look at F, I have a 2y plus 5, which is a what? Human or snowball? 2y plus 5. Human or snowball? Human. And y minus 3. Y minus 3? Human. So I have 2 humans. Is there anything I can do in this world to make 2 humans actually be the same? In real life, can you make 2 humans be the same? No. So if I could maybe take out a GCF out of one of them and make them match, or a difference of squares and make them match, cool. But can I do anything to 2y plus 5? Can I take out a GCF or anything? No, it's as low as it goes. What about y minus 3? No, it's as low as it goes. So I have to just multiply them by each other. If I can't make, you can't make them be the same, right? It's a human and a human. So 2y plus 5 and y minus 3. I can't GCF anything out to make them the same, so it's actually easy because I can't do anything. I have to just multiply them by each other. So I have 2y plus 5 here. I'm going to multiply this one by y minus 3. And then I have minus 1 over y minus 3. And I'm going to multiply it by 2y plus 5. Do we need to distribute our denominators? No. Our goal is that we need to have our denominators be the same, correct? Once they're the same, I can just rewrite it. So I don't distribute my denominators. I don't FOIL them out. I just leave them the way they are. So in the bottom, I'm going to have 2y plus 5, y minus 3, minus 2y plus 5, y minus 3. And then I just have to distribute my tops, right? So you don't distribute the bottoms because they're common denominators, there's no point. But you do distribute the top. 4 times y is 4y. 4 times negative 3 is minus 12. 1 times 2y is 2y. 1 times 5 is plus 5. Now I have a common denominator. That's my first step. Second step is to do what? Make it all into one denominator. What do I have to remember with the subtraction sign? Yeah, you have to subtract everything behind it, not just the first term, right? Will they have the error of use distributing it only to the first term? Yes, they will. It's picked more than the wrong one, or than the right one. So 4y minus 12, then I have to minus the 2y, and then I have to minus the 5. So now I wrote it over one denominator. Then I have to collect like terms, or like items. So I have 4 yams, subtract 2 yams, I'm left with 2 yams. Minus 12 nothings, minus 5 more nothings is negative 17. Is there anything I can take out of 2y and minus 17? 17 is a prime number, so there's nothing I can do. What do I still have to do? Non-permissible values, right? So my non-permissible values are going to be 2y plus 5 can't equal 0. This is in the denominator. And y minus 3 can't equal 0. This one's a little more math. I have to subtract the 5 over, so I get 2y can't equal negative 5. And then I divide by 2. So y can't equal negative 5 halves. And this one I add my 3 over. Y can't equal 3. So y can't equal negative 5 halves. true. I agree. All right. For G, I have x minus 5, which is a human. Can I take anything out of it? No. Then I have an x plus 1, which is a human. Can I take anything out of it? No. So I have an x minus 5 human and an x plus 1 human. Is there anything I could just multiply humans by and then miraculously they're twins? Is that a real thing in the world? No. So if I want a common denominator with x minus 5 and an x plus 1, I have to multiply them by each other. Okay? Try this one out. Don't do H. Just try out G, please. H has a little bit something different. Oh, we have 2x plus 1 over x minus 5. I'm going to multiply that by x plus 1. Minus sign. X minus 4 with an x plus 1. And I'm going to multiply that by x minus 5. Distribute the numerators and keep the denominators. So I get x minus 5, x plus 1. So I get 2x squared. First, outside, 2x times 1 is 2x. Inside, 1 times x is 1x. And then the last terms, 1 times 1 is 1. Minus sign, x minus 5, x plus 1. Because I can write these in any order, right? Because they're being multiplied, correct? And 3 times 2 is the same as 2 times 3, right? That's why I can write the x minus 5 first. That bottom, they're multiplied. So x times x is x squared. First, outside, x times negative 5 is negative 5x. Inside, negative 4 times x is negative 4x. And then last, negative 4 times 5 is positive 20. Now I have a common denominator, so I can write them all over one denominator. And because it's a subtraction, I have to remember to subtract all the terms behind it, not just the x squared. So I get 2x squared plus 2x plus 1x plus 1 minus x squared minus a minus, so plus 5x minus a minus 4, so plus 4x, and then minus 20. So all over one denominator, then I can collect like items. So I get 2 large xylophones minus 1 large xylophone is 1 large xylophone. 2 normal xylophones are x-rays. 2 x-rays plus 1 x-rays, 3 x-rays plus 5 x-rays is 8 x-rays plus 4 x-rays is 12 x-rays. And then 1 nothings minus 20 nothings is negative 19 nothings. I can't do anything with those. I made this aggressively long line for some other reason. And what do I still have to do? NPVs. So x can't equal 5 and then minus 1. Now h actually looks worse than it is. So I have a p squared minus 1 in the denominator and a p plus 1 in the denominator, and they look like they're both humans, and they look like we can't make them be each other. But what is p squared minus 1? Difference of squares. So we actually are going to get 4 over p plus 1, p minus 1, because that's the difference of squares of p squared minus 1, plus 2 over p plus 1. Now, is there actually something in common? Yeah, they both have a p plus 1, don't they? Yeah? So they both have that p plus 1, so I only need to multiply the right-hand side by p minus 1. So when you have humans, you always have to check, are one of them a difference of squares, or can I take a GCF so they could possibly be twins, right? So this side I need to multiply with not an eraser. By p minus 1. So I'm going to get an equal sign running down the left-hand side. 4 over p plus 1, p minus 1. Plus distribute my top to bottom, bless you. 2p minus 2 over p plus 1, p minus 1. And so I get a common denominator of p plus 1, p minus 1. And in the top, I get 4 plus 2p minus 2. And then I need to collect like items. Two picture frames. That's all there are. And then 4 nothings minus 2 nothings is plus 2. Is there anything I can do to that numerator? You can take out a 2. So the very last step, before you go to state MPVs, the very last step, say, can I do something to my numerator? In this case, you can actually take out a 2. And you'll be left with p plus 1, which matches the denominator, so you can cancel it off. But what do you have to do first? NPVs always before you cancel, correct? So what are my NPVs? P cannot equal negative and positive 1. Then I can cross those off, right? So I also stay NPVs before I cancel. And then I'm left with 2 over p minus 1. P can't equal plus or minus 1. Now the catch for I and j is you can actually make them be the same because the denominators in I have GCFs you can take out, and the denominator, one of the denominators in j, you can take something out. So let's discuss what our denominators turn to before we figure out what we have to do. So in I, what can we do with the 5x plus 5? Take out a 5, and I'm left with x plus 1. We agree? Because 5x, take out a 5 is x, 5 divided by 5 is 1. Plus 3. Take out a 2. 2x divided by 2 is x. Plus 2 divided by 2 is 1. What do they both have in common? X plus 1. So what am I going to have to multiply the left one by? Just 2, which will turn to a 10 on the denominator. And this one by a 5. Okay, we discussed that. You're going to work on it in a second. Let's discuss this one. J, I have a 1 over x. Nothing I can do to that. But then the right-hand side denominator, right-hand side on the bottom, what could I do? X squared plus 2x. Take out an x. And then we're left with x squared divided by x is x. Plus 2x divided by x is 2. And so what do they have in common? The x. And what does this one need? X plus 2. We have 8. Now, some people will write 5 times 2, x plus 1, but I did tell you that if you have snowballs can get put together, correct? So 5 times 2 is 10. You can write that together, but we're going to leave the human apart and the snowball. Plus 15 over 10, x plus 1. And then I have a common denominator of 10x plus 1. And then I have 8 plus 15, which is 23. It is a snowball. It's a great snowball, but nothing can cancel with the 23 and 10. But if something could, would you cancel it off? Yeah. Well, and we're done. We box it. We box it? Are we done? See, I made an excessively long box because I don't want to rebox it. Because what are we missing? Yeah. Does the 10 give me an MPV? No, it'd be 10 can't equal 0, which is a true statement. And then we'd have x plus 1 can't equal 0. X can't equal negative 1. All right. For this one, we get 1 distributed in, so we get x plus 2 over x plus 2, minus 1 over x plus 2. So we get x 2 in the denominator. And we get x plus 2 minus 1, which is what? X plus 1, which is a humans, right? And then an x, and then an x plus 2. Now some people try and cross this x in the denominator off with the x plus 1, but the x plus 1 is a human, and the x is a snowball, and we cannot cancel those. Correct? So we're done? NPVs. So we have x can't equal negative 2 and 0. Great. Yeah. We're flipping over. Just hurt yourself?
I hit my knuckle on my desk.
All I heard was, ow! Okay. Last two. I have x minus 1 and 1 minus x. I'm going to rewrite it as 2x minus 1 minus 1 over, how would I rearrange that? Negative x plus 1. So are they the same? No. They're the same but wrong signs. So I say they're the twin but they're dressed differently. So as long as they're the exact same but wrong sign, they are actually a twin. They're just dressed different. How do I fix the problem? Take out a negative 1. So now I'm going to get 2 over x minus 1. What can I do with that negative instead of leaving it on the bottom and having to multiply this by negative 1? What could I just do? Move it to the top. Remember, you can move a negative sign from the bottom to the front to the top. We can move it around, right? So we're going to leave the subtraction sign here. We're going to take that negative 1 and move it to the top. And now I have, I didn't change it. I took a negative 1 out and then didn't change these. Stunner. So this would be a positive x and then a negative 1. Now what do I have? Common denominators. So I can write it over one denominator. And I get 2 minus a minus 1, which is actually plus 1. So I get 3 over x minus 1. X can't equal 1. Yeah. L is very similar. I have 5m plus 1 over n minus 7 plus 4x or 4m plus 8. Now this bottom one, it's the same as negative m plus 7, correct? So it's the same but wrong sign. So can I just take a negative out? I could make it be a negative m minus 7. Can I leave the negative down there and multiply by negative 1 on the left-hand side? Sure. Or what can I do with that negative sign? Move it to the top. But remember that when you move it to the top, it has to go to both. So it'll be a negative 4m and a negative 8. And then this will turn to a positive. So we actually have m minus 7, 5m plus 1 minus 4m minus 8. And I have a common denominator, m minus 7. 5m minus 4m is m. Plus 1 nothing minus 8 nothings is negative 7 nothing. Oh, what's happening here?
No, hold up.
Halt. What's on the top and what's on the bottom?
Oh,
You can cancel, but you have to do what first? NPV. So m can't equal 0. and m minus 7 can't equal 0. That one's done. So then I add 7 to both sides, and m can't equal 7. What happens? My full numerator canceled off, so it's just gone. Left with a 1. So it's going to be 1 over m. M can't equal 0 or 7. I'm going to give you 2 questions on the board to try. So you have paper in your notes right there. You can just use that paper. Like right below where we're at, 'cause there's extra spots, right? I want you to try these 2. Can I make a plus 2 and a minus 2 be the same? Can I make a plus 2 and a minus 2 be the same? No, so I have to multiply them by each other, right? And then number 2, I have 3a over 2a plus 1 minus 3 over 4a squared minus 1. What is 4a squared minus 1? Difference of squares, so I'm going to actually get a 2a plus 1, 2a minus 1, right? So then I'll just have to multiply the left one by 2a minus 1, and they'll match. Okay? So try these 2 out. This one you're going to have to multiply by a minus 2. And this one by a plus 2. So, we have common base. We're going to write it and distribute negative 2a. Minus times a minus is plus 4 over a plus 2, a minus 2, plus 5a plus 10 over a plus 2, a minus 2. Right over one denominator, negative 2a plus 4 plus 5a plus 10 all over a plus 2, a minus 2. Then we collect like items. Negative 2 apples plus 5 apples is 3 apples. 4 nothings plus 10 nothings is 14 nothings, which I can't take anything out of that. And I'm left with a plus 2, a minus 2. And a can't equal plus or minus 2. Okay, this one I have to multiply by 2a minus 1. So I'm left with 6a squared minus 3a minus 3 all over 2a plus 1, 2a minus 1. And I can take a 3 out of the top. And I'm left with 2a squared minus a minus 1 all over 2a plus 1, 2a minus 1. Now the top actually factors, but I can't give you one that does factor because we can't make you do trinomials. Fun fact. So we would stop here. A can't equal plus or minus. I can make you solve a trinomial, but not factor.